Alright, in this video we will finally be writing our REST API. Now, as I mentioned before, we're going to be using GitHub's v3 API as our data source. So I'm going to spend a moment sort of discussing how we actually talk to GitHub servers, and as well as what kind of data that their server will return. And from that point, we'll basically set up our URLs and a data model class to represent the data which we'll be retrieving from there. And once that's complete, we'll write our REST API proper and have a look at some different configurations for OK, HTTP, and retrofit. So that's it. Let's get to it, mesdames et messieurs. All right, so as I mentioned before, we're going to be using GitHub, and the particular API that we'll be using is the v3 API. So what I'm going to suggest you do is a little quick exercise here. So I'd like you to open up just open up a browser and open up two tabs if you like. And then we're going to go ahead and click on this link here. And this is the API reference for the REST API that we'll be working with. So the reference is going to give us very important information, and this is pretty much true of any third-party REST API. So basically what we want to pay particular attention to is the API host, which happens to be laid out right here. So this is sort of like the main address for the API, and then we're going to have like sub-URLs for different parts of the API, but we'll look at that in a second. What I'm going to suggest you do is just go ahead and copy this little part here, this little URL, and we're just going to kind of paste it into this address bar. Now don't hit enter yet, but just go ahead and chuck that in there. And the last thing I'll talk about here is that the reference is going to give you lots of information. For example, it's going to tell us that we need to use HTTP methods to talk to it. And it's also going to tell us that data is sent and received in JSON. So we can expect that this thing is going to return some JSON data. So that's it. What I'm going to have you do next is we're going to click on this repositories API, which is what we'll be using to get our data from. And I'm going to scroll down to this second little section here, which is to list public user repositories for a specific user. And do note that it must be a GET request. So anyways, what we're going to do is I'm going to select this little string of text here again, and I'm going to append it to the end of our URL host, or API host, I believe is the correct name. And I'm just going to backspace and get rid of this colon username thing, and I'm just going to type in bracket cove, which is of course the URL or the username for my GitHub account. And I'm going to hit enter on that. And what I would like you to notice is that, and I would suggest you do this if you have your own GitHub account, this is basically a giant readout of a JSON-based readout of my different public repositories. So this is the data that we will actually be grabbing from the API. And I just wanted to sort of show you that in this particular case, we have an API which does give us sort of public access. So sometimes REST, in principle is as simple as just literally typing like this URL, and then you get the list of data back. Now, that's of course not going to work in our application. It's not quite so simple, but I would suggest you kind of do this so that you can kind of see, wow, this is like, REST isn't some mysterious magical thing. It's really just, typing in a URL. There will be other things like adding HTTP headers and so forth, but just in the simplest case here, we are talking to GitHub's REST API, and our browser is the client, and all we needed to do was just type in this URL, which we found from the API reference, of course. So that's basically it. What we'll do next is we'll look at sort of setting up our data model to actually consume this giant bunch of JSON data which we just received, except we'll only be consuming a small amount of it, thankfully. All right, let's get started writing some code finally. So what we're going to do is go ahead and open up the Android REST tutorial project, and if you're not sure what I'm talking about, you probably skipped the previous video and you should go watch that, or you can just clone the repository, but yeah, you go watch the other video if you haven't. It's not very long, the previous video in this playlist. And once again, I'm just going to remind everyone that in the app module, this project has two modules right now. It has, this is the completed application code. So it's the functioning application is right there. And of course we have the starting point module. And the starting point module basically just contains what I thought was an appropriate starting point to sort of start building the important stuff, which is of course the REST kind of retrofit, RxJava, etc. stuff. So what we're going to do first is I'm just going to have you right click on this starting point package here. Go to New, Package, and we're going to add two different packages. The first one is going to be Data, and the second package is going to be Data Model. Now, here's the thing about why I'm naming these things. So when you see the word data, you can kind of think in many projects this would be called model. I prefer to call sort of my POJOs and things like that as data models, and I prefer to call classes responsible for data I/O, access and storage, etc. I prefer to put it in a data class. I find that a little bit less ambiguous than model, but just so you're aware, if you're looking at a different project, generally you're either going to call this thing either data or just model to represent something like an MVC or MVP architecture. So yeah, that's basically it, and we'll start adding some code in a moment. Alright, so what we're going to do next is we are going to write our repository data model class. So we're going to right click on data model, go to New, Java class, repository data model. So basically what this class is it's sort of our Java representation of the data that we'll be receiving from the sort of JSON returned by GitHub servers. So that means a couple of things. So what I'm going to do is this class is actually going to be fairly lightweight, and I'm not going to go into a ton of detail because there's different things you can kind of do here. But to begin with, what we're going to do initially is we're going to say final string description. We're going to say final string created underscore at, and then we're going to type final owner, just like so. Of course, we haven't actually created an owner class, so the first thing I'm going to do is let's go ahead and create the owner class. So what that's going to look like is a static inner class, and like the main reason why everything is static and final and all that stuff is I don't expect this data to ever change within the flow of my application. So I'm not saying this is always what you would want to do, but in this particular case, I thought might as well make it fairly immutable. Anyways, also this will allow us to actually sort of grab the owner object, as we'll see. So this class is going to be called static class owner, and it's going to have one field, which is going to be final string avatar underscore URL. And so what I'm going to do at this point is I'm just going to lean on my tooling a little bit here. I'm going to hit Alt Enter, and what we're going to do is we're going to create a constructor, and then we're also going to create getters. Obviously we're not going to be creating setters because they're final objects, just like so. And then we're also going to do much the same with our owner class. So that's going to be Alt Enter in Android Studio, constructor, and then we want a getter as well. So that's going to be like so. All right, so we've basically created our entire data model class in like 30 seconds. These things aren't very difficult to create. Now let me explain a bit about the particular names I chose, because you're probably thinking that's really ugly and totally not camel case. So the reason why I chose these specific names and chose to even create this sort of static inner class here called owner is because that is a representation of our JSON data. So if I hop back into the response that I got, oop, wrong window, there we go. So this is the response I got earlier from the JSON data. So essentially all I did is I went through here and said, okay, what do I actually want to represent in my application? And my decision was to focus on, well, let's have a quick look at the data here. So what I decided to focus on was first and foremost, let's pull the description of the repository. As you can see right here, I'll zoom in a little bit. And then I thought, well, let's do maybe a creation date. A lot of times you kind of want like something like a creation date because it's sort of a unique ID, but yeah. So that's of course going to be down here somewhere, created at, I believe. Not super important either way, but here we go, created at. So you can see it's got the underscore, and then of course we have up here this owner sort of JSON object. So what I've done is that's why I created the static inner class. It's a class called owner, and then within that we have the avatar URL, which is what we'll be displaying in the recycler view. So basically that's why I chose those kind of funny names for these particular fields. Now here's the thing, there's a way around this that you can actually get things to work properly with prettier field names in Java. And the way that you do that is actually going to depend on which, a JSON serializer you're going to be using. So in this particular case, I'm going to be using Moshi, but you can use JSON, Jackson, whatever. For Moshi, what we do is we basically would say at JSON, like so, and then we're going to type name equals. So in this, actually, let me do the created at, that's a better one. So essentially what we could do is something like name equals, and then you give it the proper sort of JSON name, so that's going to be created at, and then what I could do is I could rename this to something like a little prettier, like creation date or something like that. Now I'm not actually going to do that because again that depends on which serializer you're using, and we're actually going to end up mapping this Pojo to a view model anyway, so it's not a big deal. But yeah, just I thought I'd give you a heads up on that. This is one of the ways that you can sort of create a Pojo with prettier names. But yeah, so that's basically it. We're going to leave that as is, and that is essentially how to set up our data model. So if you mistype these names or you don't use some kind of a mapper, then what's going to happen is you're probably going to get issues when you try and pull your data from the server, because of course it's not well-formed, not a well-formed class. So yep, that's basically it. What we'll do next is we're going to jump into some more things. All right, so the next thing we're going to do is write a little URL manager class. Now we're going to call this URL manager, and it's going to be within the data package. And this is not like something real fancy here. Basically all I'm doing here is I just wanted one place to keep track of my URLs. Now this might not be appropriate to what you're doing, or you could really just stick these strings in your adapter class, which we'll be writing next, but I really just wanted one place where I could change these if I wanted to. So let's just go ahead and say public static final string repos. First one will be called, and that's going to be sort of the path to the repos part of the GitHub API. So that's going to look like /users/ we're going to do curly brackets, super important, and that'll be a variable that we actually pass in the Java code. We'll see that later on. And then /repos. So that's all we do for the first one. I'm going to hit Control D, and we're going to type API host for this one. And I'm just going to go ahead and copy this over. You should do the same. This is just the URL that we looked at earlier. That's going to be api.github.com. So that's going to be the sort of REST endpoint. So that's basically it. And what we're going to do next is we'll actually write the adapter. All right, it's the moment that most of you have been waiting for. So what we're about to do next is we're going to write our retrofit adapter class. Now, before we do that, I just need to mention two things. So basically, we're going to be using Dagger 2 to actually create the retrofit instance. Now, if you're not familiar with Dagger 2 or dependency injection, let me put it in very simple terms what we're going to do. I'm going to take the code, which one might normally put in the adapter class itself, necessary to create our OKHTTP client and our retrofit instance, in a different part of the application. And the reason why I want to do that is twofold. When we do that, which is essentially dependency injection, we're giving an object its dependencies instead of the object creating its own dependencies. We're going to do two things there. Number one, that's going to help us when we want to test our application, because then we have some control over what we build, and we could, for example, build our retrofit implementation with a mock web server implementation. So that's the first thing. And secondly, as we'll see, since we're taking this code that would normally sit in the class itself, well, normally compared to most people I've seen implement it, we're going to move that into a different part of the app. So that's actually going to simplify our adapter class itself. And it's also going to better follow the single responsibility principle, because at the end of the day, I don't think the adapter class should be responsible for building its own stuff. But anyways, I'm going to stop rambling about that and let's get started here. So what we're going to do is right click on the data package, go to new, and this class is going to be called GitHub REST Adapter. So essentially what this class is, or how I would like you to think about it, is that this is the class where we're going to kind of adapt or create an interface between our Java application code kind of stuff, Java stuff, and then that's going to get translated both ways into sort of HTTP methods and JSON data, and that's sort of how we're going to be able to communicate with GitHub server. And how we're going to do that is through retrofit. And I think when you see how simple this actually is to do, you're going to be fairly impressed with retrofit. So how this works is we're going to create a Java interface which sort of describes our method. Let's go ahead and write it instead of me babbling about it. So we're going to say public interface GitHub service. And so what this interface is going to look like is we're going to type @get. So this is a retrofit annotation, and it's sort of indicating that we would like to set up a get HTTP method. If you're not familiar at all with HTTP, just understand that it has a couple specific methods, and it's actually like really simple, so really don't overthink this. And then so within this get annotation here, we're going to give it the URL to point to the repositories part of the GitHub API. So that's going to look like the URL manager .repos, which we created moments ago. And so this is kind of an interesting thing here. So in most implementations, if you're not using RxJava, which we will be, what the return type of this interface method would look like is you would say call, and then you would provide the data that you want to return. So list, and what did I call that thing? Repository data model. Now, why are we able to say list repository data model? This is, of course, the POJO that we created, and its fields correspond to the JSON data. But also, since we're returning a list of JSON data, we can just literally return it as a list like this, which is pretty handy. Now, I'm just going to finish this method off, and then we'll talk about the RxJava 2 part. But this is going to look like get user public repositories, and the parameters for this method, did I spell that correctly? Repositories, yes. The parameter for this is going to be @path, which is another retrofit annotation. And so basically what that's going to do, we're just going to type user. And so user is going to, when we actually create this thing, well, let's finish this off, string user. So what we're going to do is another part of our application is going to call this interface method, and we're going to pass in the username that we would like to look up. Now what retrofit's going to do for us is it's going to look at this sort of path annotation here, and it's going to be like, oh, okay, so this user variable here is what we want to substitute in this part of the sort of repos URL here. So I think that's fairly unambiguous. Basically, retrofit is going to help us build the appropriate method and URL, like where to send the method. Now, what I'm going to talk about next is that normally you would wrap this thing in a call object and return it like so. And what I will do is I will eventually add some code to sort of show you how to get the data out of the GitHub service using this call approach or call object, which is from retrofit. But what we're going to do initially is actually wrap this in a flowable object, because we're going to basically figure out how to wire up this GitHub REST adapter into an RxJava setup. So what I'm trying to say here is that I'm going to show you a way that's a little bit different, but the main change that I'm making is I'm really just wrapping this in a flowable instead of a call object. And we're going to have it sort of talking to our RxJava 2 setup instead of sort of using the call methods. Now, I'm not going to talk about what those are, but if you look up any basic retrofit implementation or look up the call class, then you're going to get an idea of how to use that. I'm pretty confident. So anyways, yeah, that is how we set up our sort of HTTP method here. And all we're going to do for the rest of this class is we're going to want, of course, a variable, or a field. So we're going to say private final GitHub service. And we're just going to call that GitHub, whatever. Could call it GitHub service. And then what we're going to do is we're going to create a single method. And this method is just going to be like basically the same as our interface method here. So what that's going to look like is we're going to say public flowable list repository data model. And this method's just going to be called get user repositories. And that's going to accept final string user. And this will make sense in a moment if you're not sure what's going on here. And then we're just going to return an instance of GitHub dot get user public repositories, and we're going to pass in our user. So essentially what this is going to do is Retrofit is going to know, and we do need to set up some configuration, which we'll see in a minute, but Retrofit is going to know that we would like to return sort of these call objects as flowables instead. And with RxJava, what I would like to do is I'm actually just going to pass this flowable to another part of the event stream, and we'll actually make the decisions about it there, which will be in another video. So that's almost it. The last thing we need to do is, of course, set up our constructor. So I'm going to hit Alt-Insert, constructor, boom, just like that. And I am going to slap an @inject annotation, which is, of course, the Dagger2 stuff. And that annotation is going to indicate that we are going to be passing in something other than this GitHub service. Actually, what we're going to be passing in is a retrofit implementation. So we're just going to call that retrofit. And then what I'm going to do is we are going to say this.github equals, where is the thing? There we go, retrofit.create. And then we are going to pass in our interface, which looks like GitHub service. All right, .class. There we go. So what's happening here is we're going to pass in this sort of pre-configured retrofit object, but what it's going to do is it's going to create our interface, our adapter, or the implementation behind this interface using the interface. So we give Retrofit a copy of the interface, Retrofit works its magic, and all of a sudden this GitHub object here is totally prepared and capable. Retrofit's going to sort out the implementation behind it, and this will work properly. And so yeah, that's basically it for writing the adapter class itself. As you can see, this is very, very simple. What we'll look at next is the Dagger2 stuff, and also, and don't worry, we won't go into much detail with the Dagger, but we're going to look at that and also how to configure our retrofit instance properly. All right, so what we're going to do next is we're just going to hop into this class in the DI package called application module. Now, again, I've mentioned this before, but if you're not clear on what's going on with Dagger2 or you're not familiar, that's totally fine. Understand that the reason why I've done this is I wanted all of this code to not exist in, say, here, which is something you could do. It's just if you do this, you have to be aware of how many instances you're building and things of that nature. And that's part of the reason why we use Dagger2 to handle that. But anyways, longer story shorter, I don't want you to get overwhelmed about what's going on. We're literally just moving that code out of here and putting it in here. And because we've slapped this inject annotation on, and because of all the configuration of Dagger2 in this case, just understand that this thing will be given a retrofit instance when it's created. So let's have a look at the different sort of components necessary to actually build this retrofit instance. So the first thing is when we're creating retrofit, it needs an HTTP client. Of course, we're going to be using OKHTTP, which is sort of the industry standard, and it's also a Square library, so I think they generally tend to work pretty well together. And what that thing's going to look like is from sort of like a basic standpoint, you could pretty much just get away with like building that essentially, OK HTTP client.builder, and then we're passing this client into our retrofit instance down here. Now we can add all kinds of configurations. So there's a couple different ones. We've got this add interceptor. We're actually going to look at that in a different video, but this is going to be how we can intercept errors, or one method to deal with error handling. And then there's also a couple different things like, for example, we're just specifying different timeouts. So if a request or response or something like that is taking too long, then we'll kind of have our stuff throw an error. And we don't need to worry too much about that. And of course, if the connection fails, retry. But again, this stuff is really going to depend on your project's requirements, but I'm just demoing a couple things there. So we build our OK HTTP client, and then the next thing that we do is we configure our retrofit instance down here. Now again, there's a whole bunch of different things you can do, and because they've used the builder pattern, which is this dot, etc., dot, 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 all these chained methods, it's the builder pattern, it's kind of neat. What we can do is we can configure, of course, the client that we'll be using. We can configure the base URL. Now, as we'll see later on in another video, we're going to look at testing this thing with mock web server, and we could actually pass in the mock web server URL in here, which we'll do later. But what we're passing in here is we're saying, okay, this is the base URL, and then what I've added in here is a converter factory. So there's different converter factories which Retrofit is compatible with. Like there's Jackson Converter Factory, JSON. Go ahead and check out the Retrofit Square website, and they'll tell you about all the different factories that are compatible. And we also have this add call adapter factory, and this is what's going to allow us to return flowables or observables instead of the call objects. So that's basically all we do when we configure this retrofit instance. And of course, this is what we'll be returning in our method here. And so that what ultimately ends up popping up here, and that's where we create our sort of interface proper, or create the implementation behind the interface. So that's basically all we need to do to build and set up a working implementation of Retrofit. Now, of course, we haven't coded the stuff that the rest of our application will use to communicate with it, but this is fundamentally all you need to do to create a retrofit instance. So we have a, let me switch to cam mode. So we've got a data model class to represent the data we'll be returning. We've sorted out our URLs. We've configured our OK HTTP client. We've configured our retrofit so that it's got some kind of serialization library to go from JSON to Java objects. And yeah, that's basically it. We've also added the RxJava2 call adapter factory, blah, blah, blah. In a nutshell, what we have now is a working adapter, which another class, which we'll be coding later, will talk to. And we're creating that retrofit instance in a separate area, which is going to afford us some bonuses of following the single responsibility principle, and it's going to make testing easier down the road. So that's basically it for this video. Yeah, if there's any final notes, I'll babble about it in the outro. All right, folks, that's basically it. In the next video, we will write the code which will connect our retrofit adapter to the rest of our application. Yep, so that's it. If you liked the video, please do me a favor, hit the like button down below and check the pinned comment for more options to support my efforts, should you like to. And that's it. Hopefully you enjoyed that, and we'll see you in the next video.